Hi there. Today we're going to be looking at interpreting graphs using the graphing calculator. And there are some instructions for Desmos on here too. Desmos is very quick, very easy. The issue with Desmos is that it's not allowed on in-class testing because it needs internet and there are other things that could be accessed. It's also not allowed on the SAT, ACT. So that's why we're going to look today at how to do things on the graphing calculator so that it's something that you'll be able to use on things like standardized tests and in-class testing. And to do that, we're going to look at one particular problem. It is about a water balloon. So a water balloon is launched from a dorm room window. Its height in feet after t seconds is given by this equation. H of t equals 128 plus 64t minus 16t squared. So h of t sometimes is used for like the height at a certain time, and that's why they use t here. Well, in our graphing calculator, we're going to enter that equation into y1. Now, I know this says h of t equals, but we can really think about this as a y. And in the graphing calculator, it's going to be best for us to think about the variables at this point. Our input variables could be x. So instead of t, we'll put an x, and instead of t squared, we'll put an x squared. So I invite you to go to your graphing calculator. If you're not in this screen, if you're just on the home screen when you turn it on, to get to y equals, you simply go to the upper left and you hit the y equals button, and then you can enter in that particular equation. And then you just type it in. So 128 plus 64, and then notice that the x is up to the alpha key. And then minus 16x. And now to get the squared, I'd go on the left column, and then you should see an x squared key. And that's a nice way for you to have that. So we've got our equation in y equals. And as indicated on the paper, to get to the table on the calculator, we just press second graph. So let's try that. And notice that this gives us a nice table of values. Oftentimes, if you haven't fooled around with the table, it's defaulted to automatically go by ones on the x, and then it'll tell you the corresponding y values. And we can see that we can easily fill in the table with the values that I'm seeing on the screen. The table that you're asked to complete has you filling out the values from 0 to 6. And notice that this calculator does that as well. And again, hopefully you got that in your calculator that you're using, the graphing calculator that you're using. Hopefully you are following along with this. If not, pause when you need to and make sure that you can get to something that looks a little like this, all right? And so now we have our table filled out. I do think it's a good idea for you to put what these pieces represent. I know in the graphing calculator we used x, but this really represents t, the number of seconds. And in the graphing calculator we used y for the output, but that really is h of t equals the height. It's really like our output. So notice that I didn't bother going like up to 10. 10's a nice number, so why'd we stop at 6? Well, let's see what happens here. What happens is that our height looks like it goes up, it starts going down, and then here it's negative. Does that really make sense? Not so much. So why would we bother going to a negative height? I know that there's, below sea level and stuff, but when you throw a water balloon, I don't think it's going to go 64 feet below the surface of the earth. So why does the table stop after 6 seconds? All right. Notice that we see at 6 seconds, the height is negative. Which doesn't make sense here. So there's no need to continue. okay? So again, we could have gone on and on and on, but there's really no need to see what happens after 6 seconds, because I'm kind of doubting that that water balloon got even that far below the ground. So the next thing we're going to do is to talk about the window on the calculator. Again, I know Desmos is nice because you can like drag it all over the place. There's a little more work involved in the calculator. So we need to adjust the window on the calculator to view the function. We want to be able to see the maximum height on the balloon and when it hits the ground. So let's look at what I usually suggest for a window, which is zoom 6. And then we'll see what that gives us. So let's go to the calculators. Notice zoom is up here on the top, in the middle here. If I press zoom, and then notice that number 6 is standard. If I hit, and all I have to do is just hit the number 6, it'll automatically select that 6 for us. And that's the graph that we get. To find the window, notice between the y equals and the zoom, there's a window button. And if we click the window, we see x min, x max, which means that that's the lowest point on the x-axis and the highest point on the x-axis that we'd see, and the x scale, which is like how your tick marks would go. The same is true for the y min, y max, and y scale on the y-axis. So anytime you do zoom 6, that's what you're going to see. So don't worry about the res and all that kind of stuff here, okay? But let's go back to our paper and write what we have in the current window. When you zoom 6 it, it always goes from -10 to 10 by 1s on both the x and the y-axis. But what we found when we were looking at that graph is that it wasn't really conducive to kind of like looking at what the graph looked like. If I look at the graph, so if I go back to graph, which is, so not second graph, because second graph brings us to table, but just hit graph, notice that I know that this should be a quadratic, and that just kind of looks like two parallel lines. They're not, they're a little, they're slanted in a little bit. But I mean, I want to see the vertex of this graph if it's a quadratic. So let's kind of think about what we could do. We're throwing a water balloon, right? And if we're throwing a water balloon, that's, and x is representing the amount of time that is going on, the water balloon isn't going to be in the air for a really long time, okay? So if I go to my window, what might be a time that we start with? Well, I always think in context that 0 makes sense, because at a time of 0, that means that no time has gone by. That means that's where you're starting. So if you put 0, I get it. But one thing that's nice is to be able to see the axis, like give it a little bit of a buffer. So if I'm going to start at 0, I might actually start at -2. At -2, just to give it a little bit of a buffer. And then I just press enter to get to the x max. My x max is 10, which means that 10 is the maximum amount of seconds. I could do that if I wanted. We could also think back to the table and remember that after 6 seconds, it started being negative. So maybe I don't want, to have anything much past 6. So maybe I want it to go a little further. So maybe I go to 8. Okay. Again, there's no wrong thing. So like if you had 10 as the x max, great. If you had -10 as the x min, that's fine, because we were able to see on the x-axis the points where it crossed. And then for x scale, if I was going by -2s to 8, graphing by hand, I'd go by 1s, so I like the scale. But let's look at the y. So I just arrowed down to the y min. Notice that the y max doesn't seem to be big enough. And this, the balloon is being launched, like thrown up from a dorm room window. Notice that if we look at the equation, the y-intercept is 128 feet. So like it's probably going to go up from there, so it needs to be bigger. So maybe we would guess 100, so maybe we would go from -10 to 150 for the max. And if I was graphing that on a calculator, like by hand, I would not go by 1s. Maybe I'd go by 10s. and I can see what that looks like on the graph. Now, I did that on purpose to show you that when you try windows, sometimes you have to try it more than once. Notice that the top of this graph is still cut off. So what about the window would I need to change to see up more? Well, I'd go back to the window and arrow down until I get to the Y max. Maybe I could try a Y max of 200 instead. And again, the Y min, I set it as below the axis just so that I can see the axis when I'm graphing. So let's try that. And I can graph, and that looks much better. Okay, so the window is not like a formula that you will all have the same window. You just kind of play with it a little bit, but think about the context of the situation to see what values you might use, and that can help you in your window. So let's write these values of the window down on our paper. So what we ended up with for the window was an X min of -2, an X max of 8, and a scale of 1. Again, these can vary. The Y min we set as -10. The Y max we set at 200, and the Y scale was at 10. Again, these can vary. If you see those on an answer key, yours might not match, but as long as you are seeing the full graph, like if it's a quadratic that you can see the vertex, that you can see the x-intercepts, then you should be okay, all right? So that's how you adjust your window. Again, it's not an exact science. You kind of got to play around with it a little bit. So the next question asks, what is the height of the dorm room window? So when we talk about the height of the dorm room window, I want us to look back at the original problem and what the dorm room window was. This is where the water balloon is launched from a dorm room window. So that means the dorm room window is where it starts. So where does it start? And oftentimes we say that things start when the time is 0. And if we put 0 into t, then we see that that's going to be 128. We see in the table that it's at 128. If we look at our graph, then you can press graph to look at the graph. Notice I went by 10s, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 20. So it's between 120 and 130. You can see on the graph that's where that value of t was going to be 0. So when it wants for the height of the dorm room window, we can say that the dorm room window is 128 feet from the ground. And then again, if someone said, okay, well, how do you know this? Well, we know that this is the height of the balloon, because that's what we were throwing, when t equals 0. And that essentially is the y-intercept. So notice, because this equation is in standard form, we also could have seen that that was the starting point in context, because the y-intercept is usually a starting point in context with time, because time, usually we start something when the time is 0. And we know that when an equation is in standard form, that we can look at the c value and we can tell what that's going to be. Okay. So we didn't even need a calculator for that, just kind of talking through what a y-intercept is. The y-intercept is like a starting point in standard form when t is 0. All right. So let's look at the next piece here. The next piece asks for the maximum height of the balloon. and when it reaches its maximum height, and I put this line in the wrong spot. And to answer those two questions, when we see this maximum, oftentimes we think about our vertex. And so let's talk about how we can use the graphing calculator to find the vertex. And so these are the steps. We press second trace, which brings us to the Calc menu. And that does a lot of different calculations for us. So we can calculate a maximum or a minimum, and you press number 4 or 3 dependent. Okay. Then what you have to do is you press the left arrow button to the left and press enter. Press the right arrow button, make sure you're to the right, press enter. It says guess. Usually there I move it closer. You press enter, and then the max min is listed on the bottom. So if we go to our graph and we follow those instructions, we hit second trace, because that brings us to the Calc menu. Because I'm looking for a maximum, I would hit number 4. Now right here, there's the little cursor, or some people call it a little spider. I don't like spiders, so I'll be calling it a cursor. Notice that step 2 is to press the left arrow button over to the left. So we press it over to the left, you can press and hold it. And like this is to the left, okay? That's still to the left, okay? Like just somewhere to the left. Like up here, let me do this. Like up here looks like that's where the vertex is. So go to the left somewhere, I don't care where. And then you press enter. Step 3 is to arrow to the right. So here we're at the top. We want to make sure we're over to the right somewhere, and then press enter. Notice now at the bottom it says guess. I like to move close to the point. You don't have to, but I like to move close to the point and then press enter, because it's like asking me what's your guess, and so I like to think about that as moving to the guess. But then it'll move to your maximum. Now notice that this maximum is at 1.9999, you know, there are a lot of 9s. What do you think that number really is? It's probably 2. Just so you know, in the calculator, when it's doing these conversions, when you use the second trace menu, sometimes the values don't end up as integers, and that just has to deal with the pixels in the calculator. And someone else might not have gotten 1.999. Someone else might have gotten like 2.0000, you know, like 13 or whatever. And it depends on like where you put your left bound and right bound there. But again, it just deals with the pixels of the calculator. That really means that the maximum is at x equals 2, y equals 192. So let's write that down, that the vertex we got was at 2, 192. Now, when they want the maximum height, what is the maximum? Is the maximum the x coordinate or the y coordinate? Remember that the maximum height would be the y coordinate of our vertex. So the y coordinate of our vertex would be 192. So the maximum height of the balloon would be 192 feet. So I'll just write 192 feet is the max height. Okay. The next question asks, when does the balloon reach the maximum height? What do you think we'd look at for that? Well, we didn't touch this 2. What do the x coordinates represent in this problem? They represent the time. So this when is going to be the x coordinate of the vertex. So the y coordinate is the max itself, but sometimes the x coordinate can tell us how we get there, or in this case, when we get to the maximum. So because we have that, the x is 2, when does the balloon reach its maximum height? This would be after 2. And then I believe the original problem said that the time was being measured in seconds. So it would reach its maximum height after 2 seconds. Okay. So that's how we find the maximum. or minimum, you do the same thing, go to the left, to the right, etc. For a quadratic. So letter G is asking us, what is the height of the balloon when it hits the ground? Well, when it hits the ground, how high off the ground is it? Well, that would be 0 feet. So when it hits the ground, the height would be 0 feet. So when we talk about the next question, which is when does the balloon hit the ground, we're looking for times when the height is 0. What is the height? Was the height x or was the height like our y? That is like our y. So this is asking when is y equal to 0? And the nice thing about the y being 0 is that those are very special points. Those are called the x-intercepts, right? So where are the x-intercepts? Remember, because x-intercepts are a number, comma, 0. So that means that y would be 0. And so the next thing we'll investigate to find when things hit the ground or when we're trying to find for the x-intercepts is we can look at the steps to find the zeros of a graph. And notice the zeros are like the x-intercepts. The difference is that zeros are written as what does x equal, and that x-intercepts are written as ordered pairs. But those are pretty synonymous, like they go hand in hand, it's just the notation that is different. So here's where we find the zeros of a graph. We're going to hit, again, second trace, but this time go to 0. I know these are x-intercepts. That's different than intersect, all right? And again, an x-intercept is a 0 of a graph, so we'll go to 0. Again, we're going to arrow over to the left of the 0 and press enter. To the right of the 0, press enter. Guess, where I like to move close, press enter. And then the 0 is listed on the bottom. So let's go back to the graph and try that. So if I go to the graph, I can again follow step 1, hit second, trace, and then number 2 is a 0. So I know there are 2 x-intercepts. Just for practice, I'm going to move to the left and right of each. So I'll start with the one on the left. So I'm going to move way over here to the left. And notice that to move to the left of the 0, I did need to see that axis a little bit. So that's why I left that buffer in the y-min. So notice that when it's increasing, all right, that the left is below the axis. So that's to the left. I'm going to press enter. Now I need to arrow over to the right. And now notice that the right is above this one. I press enter. It's asking me to guess on the bottom, so I'll move close and press enter. And notice that one of the x-intercepts that it gives me is negative 1.464102. Now, if I look back on to the question, this asked me to round to the nearest hundredth. And the nearest hundredth means that that's going to be 2 decimal places. So if I look back here, I look at this, I don't know if you can see my cursor in the video, but I look at this 6. To the right of the 6, because that's 2 decimal places, to the right is a 4. 4 is smaller than 5, so that means I'm going to keep it at negative 1.46. So I'm just going to make a note here that as far as the x-intercepts go, that 1 is at negative 1.460. Okay. But there was another x-intercept, wasn't there? So let's go to the next x-intercept. I'm going to hit second, trace. Number 2 is 0. And I want to arrow over to the left of it. And I know I was on the left, but I would go a little closer so it doesn't confuse the calculator. It's not as smart as y'all, okay? So notice that this is to the left of where it crosses the axis. Notice this time the left is above the axis. So we press enter. And now I go to the right of it, and sometimes it might disappear. That looks like it might be to the right. If you're nervous, you can just, hit it again, make sure it's to the right, press enter. And then the nice thing about the fancy CE calculators is you see that they make lines. And as long as that x-intercept is between those lines, you should be good. Anyway, so for guess, I'm going to move close to it. That looks pretty close. Press enter. And again, round to the nearest hundredth. That's going to be 5.46. So the other x-intercept is 5.460. Now, do both of those make sense? This would mean that this was at negative seconds, and that's at positive seconds. Well, we know that negative seconds don't make sense. So we disregard this because it doesn't make sense in context, and we would use the one that makes sense. So this balloon hits the ground after about 5.46 seconds. Okay, so again, in context, so graphically, algebraically, there were two zeros that represented, that ended up giving us two x-intercepts on the graph. But in context, only one of those x-intercepts makes sense, the positive one, because our x was dealing with the time. Okay? So there's one other thing that I want to teach you how to do in the calculator today, and that is how to find the intersection of two graphs. When might you want to find the intersection of two graphs? Well, let's take a look. This wants the times rounded to the nearest hundredth when the balloon will be 150 feet in the air. So what is this question really asking? This question is really asking, when is the height (150 feet? Which was the height? Was the height the x or the y? The y. So we want y to be 150. So we want y to be 150, and then for us to be able to find the x values that would make that true. So what we can do to do this is we're going to make a new equation, and we're going to put y2 equals 150 into the calculator. Maybe instead of put, I should have said let, sorry. So we're going to let y2 be 150. Okay, bear with me. So go to the calculator. Remember, if I want a new equation, I go to y equals, and then I'm going to arrow down to y2, and in y2, I can hit 150. And then I'll just graph, because I should have everything set up. The window will stick, whatever you choose will stick. So I can see that there are 2 points over here on the left and on the right where they intersect. So how would I find those points of intersection? Well, what some people do is they try to trace, and they use the arrows, and they're like, oh, it's pretty close, it's about right here. Okay, some people want to try to use the table. Notice that there isn't an exact point here where it's 150. So like I can kind of see it's between here and here that it's going to be 150, so between 0 and 1, but that really doesn't help. And again, if you're on the graph and you try to trace, I mean, how do you know if you're in the exact right spot? So to help, you can use these steps. You're going to hit second, trace, one more time, like once again, and then we go to number 5, which is intersect. Then you just go close to an intersection point, and as long as you only have 2 equations in there, you can just press enter 3 times, and that'll give you the intersection point. So let's look at that. So if I go to the second trace, and I go to number 5, which is intersect. So again, I'm going to scroll close to where it was. I already did that. So we'll try this one first. And the reason you press enter 3 times is notice on the bottom it says first curve, and notice at the top it has the equation for y1. You're telling it, calculator, I want you to think about y1, enter. Now it says second curve and then y2. You're saying, calculator, I want you to think about y2, enter. And then guess, you're already close to it, enter. And then that will jump to the x-intercept, which is going to be the 0 of the function if we look at the x value. So notice to the nearest hundredth, that gives me about 3.62. So I'm going to just make a little note that there's an x-intercept at 3.620. But I noticed there was another one, so I can go back to the calculator. And again, I'm going to do second, trace. Number 5 is intersect. Oops. Of course. Second, trace. Number 5 is intersect. And then again, I'm going to scroll to a point of intersection. Always use the left and right arrows. Don't use the up and down arrows when you're moving along a graph. Okay. So that looks pretty close. And so now once I'm close, I just hit enter for y1, enter for y2, enter for my guess. And notice this is 0.3798. If I go to the nearest hundredth, I look at the 7 and look to the right, that 9 bumps it up to 0.38. So I'm going to write that my other y-intercept was 0.380. And so then these represent that, oh my gosh, it's not at 0 because these aren't x-intercepts, guys. These are intersection points. Sorry. So this should be at 3.62, at 3.62, 150, and at 0.38, 150. If I use this video several years later, just like it's 2020, so it's Rona times, so everyone's head's a little jumbled. I apologize. All right. Anyway, those are the points of intersection, which means those are the times that the balloon will be 150 feet in the air. Remember, these represent seconds, so we can say that the balloon will be 150 feet after about, I like saying about when I'm rounding, 0.38 seconds and about 3.62 seconds. Okay, so that would be